In this class, we're going to take a look at how you work out the trig exact values for what is called multiples of common angles. So the common angles are 30 degrees, 45 degrees and 60 degrees. There's a method for working out sine, cos and tan of those values, and we'll partly talk about that today, but we're going to focus on multiples of those values. So for example, if you wanted to work out the sine of 240 degrees, 240 is a multiple of 60, there's a way to work that. So we'll start with a quick recap. So this is what is called trig exact values. And we basically get these exact values from using SOHCAHTOA, the trig ratios, and using SOHCAHTOA on these two sort of special triangles. So the first one, I mean, these triangles you just need to know. So the first one has got 30 degrees like down here and 60 degrees up here. You can reorientate the triangle. If you're used to seeing it in a different way, that's fine. This is just the way that I draw it. So the important thing is you've got the right angles, and more importantly, you've got the correct side lengths in the correct place. So this triangle's got a 1 here opposite the 30. It's got a 2 on the hypotenuse, and it's got a √3 down there. So you just need to basically learn and remember that one. And then there's another one, which is a bit more symmetrical because it's got 45 degrees here and here, and then it's also a right-angled triangle. And this one has side lengths 1, 1, and then by Pythagoras this would be √2. Okay, so these are like our starting point, these two triangles, and we're just going to kind of build on those. But just a quick reminder, or if this is new to you, just to introduce you to this idea, that we're going to use SOHCAHTOA on these to work out certain values. So let's say, for example, we wanted to work out the sine of 30 degrees. So 30 degrees is our reference angle. That means that this becomes opposite. This is the hypotenuse, the long side, and this is adjacent. So if we wanted to work out the sine of 30 degrees, we would just take a look at that triangle and say, right, well, we know from SOHCAHTOA that sine is opposite over hypotenuse. So opposite over hypotenuse. So that tells us the sine of 30, opposite is 1, hypotenuse is 2. So the sine of 30 is just 1 over 2, 1/2, okay? What we're going to do in this class though, we're going to extend this idea beyond these common angles, 30, 45 and 60, to consider multiples of them. It's really tempting to say, well, don't I just take the number and multiply it so that the sine of 90, for example, would be 3 times that? It doesn't quite work like that because remember, these are angles we're putting in here. And it just doesn't, I mean, this is partially a geometric thing. It doesn't really work by just multiplying that up. In fact, if we wanted to multiply that by 3, what we would actually be getting would be 3 sine 30, which would be 3 over 2, not sine 90. The 30 is kind of locked up inside the sine function. So that's not our approach. What our approach is revolves around using these two triangles and also the cast diagram. So if you're not familiar with the cast diagram, maybe check out the class on that topic first, and we're going to merge these two techniques together. So let's take an example. Let's say we want to work out the sine of 120 degrees. So can't quite do it directly from the triangles because none of these triangles have got 120 degrees on them. But what we can do is if we take a cast diagram, and I'm just going to label it in the usual way, CAST. Again, if this is unfamiliar to you, maybe check this out first or else this could be a little confusing. So we're going to measure on or mark on 120 degrees, starting from 0, going backwards, counterclockwise. So 120 would be round sort of there somewhere. So I'm just going to mark that on like there. So we've turned basically 120 degrees. So this angle in here would be 120. So if we turn 120, this straight line obviously makes 180 degrees. That would mean that we're left with 60 degrees in here, okay? What that tells us is there's some relationship between the sine of 120 and the sine of 60 degrees. So when you mark on this angle and then make a mark and then work out the other angle, there's some relationship between those two angles. And that's just a way that the trig functions work. How we take this forward is we then turn this into, there's different ways to do this. This is the way I'm going to do it. We turn this into a right angle triangle, put in the other reference angle, which now has just made it into this triangle here. although kind of spun around the other way. Mark up the sides. You could even pull this out and make a separate diagram if you wish. I'm just going to mark it all on here. So marking up the sides, that would be 1, 2 and root 3. So all that we're doing is we're saying, right, okay, well, we're kind of transferring the sine of 120 to the sine of 60. Imagining we don't have this for reference at the side, we would go to our triangle and say, okay, 60 is our reference angle, that's going to be opposite, that's hypotenuse. Sine is opposite over hypotenuse, so it's going to be root 3 over 2. So the sine of 60 is root 3 over 2. That might be the final answer. The only other thing we've got to check is which quadrant we're in the cast diagram. Now we're working with a sine function and we're in the sine quadrant where sine is positive. So we just basically leave that. I mean, it's going to be a positive. We don't write in the positive, but we just leave that. If, however, we had done the same thing, but we had landed, say, in the third quadrant, we would need to put a negative in front because sine is negative in the third quadrant. So it's a combination of using these triangles and the orientation that we get from the cast diagram to figure out what the value is going to be and then whether the value is going to be positive or negative. Okay, so we'll show you another one. Let's go for the cosine of 225 degrees. This is always a tricky technique at first. Don't expect to look at this and be like, oh yeah, that makes sense. Like, it's going to be tricky at first. You might need to work a few example questions to get a feel for it. So going through the same process, we're going to mark up a cast diagram. Just put on the labels if you wish. C-A-S-T. Mark on 225. So 225 is going to spin us round past the 180. I'm just going to move the T to get it out of the way a little. So it's going to move you past the 180 to down here. So if we were to turn all of that into an angle, then it would be 225 degrees. The angle that we've created in here is therefore 45 because the straight line's 180. So we'd leave 45 to get up to 225. We're going to create a right angle triangle again. So this is always part of this process. You mark on the angle, then you create a right angle triangle, and you make the right angle triangle at the origin and also with one of the sides connected to the horizontal axis, right? So here, basically, and here, rather than making it vertical, like in here somewhere. Okay, so try and remember that. So we've got it marked up, and then we just need to put the labels on our triangle. This would also be 45 degrees. This triangle we know is 1, 1 and root 2. So this side length is 1, this is 1, and this is root 2. 45 is our reference angle here, so this would be opposite. This is hypotenuse and this is adjacent. We want cosine. We know now that cosine of 225 must have some connection with the cosine of 45 because we've transferred that 225 to our new reference angle, which is 45. Cosine is adjacent over hypotenuse. So adjacent is 1, hypotenuse is root 2, so the cosine of 45 is 1 over root 2. We might be done at that point. We're just checking now which quadrant we've landed in. We've landed in the third quadrant, the tan quadrant. So in the tan quadrant, cosines are negative, so we just put a negative in front, like that. Another way you can think about that, which should give you the same information. If you draw a cosine graph, if you're familiar with the cosine graph, cosine of 225, well, this is 180 here. This here is 270. 225 is somewhere in between the two of them. So 225 would be, say, like here somewhere, going along the way. So 225. Taking that back over to the y-axis, you can see that this is below 0. So in other words, it should be a negative value. So that can also help you to get orientated with these positive and negative values. But we don't really need that because the cast diagram is already telling us which quadrant each of the trig functions is positive and negative in. This tends to be quite a difficult technique to learn at first. It takes a little practice. You need to start by knowing these triangles. Once you've got those, just testing your ability to take them and transfer them over to other angles. So yeah, definitely try a few practice questions on this topic.